Hi everyone, this is Dr. V.S. Nisho from AC Department, SNS College of Technology. So we are going to discuss the topic power dissipation from the unit combinational logic circuits. So here we need to know why power is very important and what are the ways it is dissipating and what are the ways we can improve from power dissipation. First, why worry about the power? So we are in today's world we are using several electronic devices. So that is battery powered devices like GSM phone and MP3 player and so many etc. And whatever devices with a complex complexity or normal speed. So there are several problems are there. There are like thermal problem and expensive packaging. So this and all leads to the power dissipation. So this power dissipation will affect the performance, reliability, packaging, cost and portability. So coming to the point, overview of power dissipation or consumption. So what is the main source? What is the main source of power dissipation? So that is classified into three. So that is static power dissipation, dynamic power dissipation, and then short circuit power dissipation. So the where it happens. So static power dissipation, that is due to leakage current when the circuit is idle, and dynamic power is told to be circuit is on when the circuit is in working. So during the switching activity there is power dissipation, that is called as a dynamic power dissipation, and similarly short circuit power dissipation. And then the total power dissipation is calculated based on dynamic power along with short circuit power and then leakage power and short circuit and static power. So this everything gives the total power dissipation. So dynamic power. So dynamic power dissipation occurs when the MOS transistor switches to charge and discharge load capacitances. So during the charging and discharging of the capacitor across the output path, there will be the power dissipation occurs. So that is called as a dynamic power dissipation, and it is given through the equation P dynamic is equal to CL into VDD square into F. Here CL stands for the total output node capacitance and VDD stands for the supply voltage and F stands for the operating frequency. So this dynamic power dissipation depends on these three different factors. On short circuit current. So here it discusses about the short circuit power dissipation. So here 15% of the power dissipation is from dynamic power and approximately 85% based on the charge across the capacitance. So and while seeing when the input is changed in any circuit or transistor, the output also vary based on the input. So there is a deviation when the input is changing, output should also vary immediately within few seconds, few microseconds. But if the output is varying after that few microseconds level, so that represents there is a delay or power dissipation in the circuit. And then leakage. So here we are discussing about the subthreshold current. The transistors conduct below Vt. So if the transistor conduct below Vt, so this will occur. So across the transistor or across the diode, when the current reduces because of this transistor conducts below Vt, so that represents the subthreshold current. And here is the plot for the subthreshold leakage component based on the threshold voltage 0.1 volt and 0.4 volt across the transistor circuit. So this and all below threshold voltage level. Static power consumption. So here due to the diodes or any transistors, there will be a power dissipation that is called as the static power consumption. So when the output is low, so the power consumption even without switching activity it takes place. So that is static is nothing but in an ideal condition there will be a power draw. So that is the main concept of static power consumption. So here is a brief table based on the different components and different companies based ICs, how the power dissipation occurs. So P total for Intel, so that is 1.41 watts, and P total for DEC alpha ICs, that is 32 watts, and cell based ASIC, in ASIC 0.8 watts. So comparably, the Intel and ASIC ICs having less power consumption when compared to the DEC alpha 21064 ICs. So this is in-depth. If you are going for in-depth, means logic gates based power dissipation, clock distribution based, interconnect based, IO, that is input output driver based power dissipation, everything is discussed here. So here in this topic we have seen what is the importance of power saving, energy saving, and then what are the sources of power dissipation and how it is calculated. So based on that we are having a short assessment here. Which of the following is the source of the leakage current in CMOS circuits? Subthreshold leakage. The total power consumption in a digital CMOS circuit is given by P total equal to P dynamic plus P short circuit plus P leakage current plus P gate current, and then the dynamic power in CMOS logic is calculated as CL into VDD square into frequency. So that's all about the today's topic. We can join in the next video.